everyone. Yeah, my name is Bugaev and I'm Chief Technology Officer at Flow. And I worked there already 4 or 5 years. We started as a very small startup, 10 engineers in one room, and now we have around 150 engineers. So whatever I talk now, it's more applicable to kind of bigger scale and it's more like a recent state of the art at Flow. But yeah, you will see a lot of interesting stuff. And today I'm going to talk about architecture. And my definition of architecture is it's important stuff, whatever that is. And yeah, first of all, I want to talk about Flow a little bit. And we at Flow, we aim to be the essential health partner for 1 billion women worldwide. And we already have 250 million of users. So we are almost there, yeah. But yeah, we still need to do a lot of stuff, and for in order to become this essential health partner, we at Flow we develop a mobile application. Basically, it's a health tracker. We have chatbots, community, cycle prediction, different health patterns, and so on. And basically, we try to collect data from different devices, including wearable devices, and then we analyze this data and we provide some kind of actionable feedback, what to do, whether to go to doctor or, I don't know, maybe to change some behaviors in life. Yeah, so this in short about Flow. And as I promised, I'm going to talk about architecture. And I already said my definition for architecture, but I'm going to repeat it. So architecture in my world is about the important stuff, whatever it is, and it's important to decide what is important. Yeah, so and then you need to keep this important stuff in a good condition. Yeah, and I also want to say that it might different things are important for different companies, for different systems, and sometimes name of the field or additional field of API might be more important than the whole kind of technical stack, database programming language, because sometimes you can rewrite the whole microservice from one technological stack to another in 1 week. And sometimes when you migrate from one API to another API, it might take years, and you will lose a lot of clients because of that and so on. So it's very hard to say what is important for a particular company or for a particular system. So you always need to think about this in that way. So sometimes naming important, sometimes technology stack important, sometimes other things. And at Flow we have a lot of important things, and our system is super personal. So it means that we kind of use a lot of data about user to predict certain kind of health issues, conditions, and so on. So personalization is important for us, and I'm going to talk how we decided to implement personalization in Flow. So it might look like an anti-pattern at first look, because basically we have a lot of systems like cycle predictions, health score, something about pricing. I think you already heard a lot about pricing today, but yeah, basically we also have pricing at Flow, and we gather all this information about user into one central storage, which is called user profile. It's actually not a database, it's there is an API on top of it, but basically from all this system we send data to user profile, and in user profile for every user we have a lot of attributes, whether it's what is the age of the user, I don't know, different health scores and so on. And then for sure some of these interactions are asynchronous, some of them synchronous, but in general it looks not very good, because basically a lot of systems they write to one system and they also consume data from this one system. And basically it also means that this is one kind of it's one single point of failure. So whenever this system is down, all other systems they also can function properly. And when I'm talking about other system, I'm talking about at Flow we have personalized content, and we show this content based on user profile. So basically in our CMS system we have sorry, it's a different device. Yeah, it's not that important maybe. So yeah, we have CMS, we have different conditions, and based on these conditions we show content at Flow. We have experiment service, we can show feature based on certain attributes of the user. So we can show certain features for, like, I don't know, for teenagers, and we can show like different features for other people, and we can run like A/B test experiments based on this user profile. So whenever user profile is down, like this experiment service is also not working because we can't attribute like different experiments to different user groups. And we also can send like notifications based on the user profile. So a lot of things. But yeah, we decided to do that because it's important for us to have this single view for the user. It's important for us to have like a digital avatar of the user. So maybe this architecture is not perfect, but it's an important decision, and we made it, and we use it everywhere at Flow. Another important thing for Flow is privacy, and we have a lot of features that are designed in a different, like in a certain way to protect data privacy, to protect privacy of our users. And one of these solutions that we have in place called Oblivious HTTP. Actually, it's not like a solution; it's more like a standard. It's still in draft, so it's like not widely adopted as, I don't know, normal HTTP or, I don't know, TCP, UDP, whatever. But I think it's kind of emerging standard, and it will be super important. I know that Apple already uses this protocol in some of the systems because Apple also very focused on privacy. And at Flow we also implemented this solution. How it works? So basically, you know, like with every API request, client sends original IP address of this client. And when you have API address, it means that you can detect, like, you can say a lot about this user. Sometimes you even can identify this user precisely because, like, I don't know, maybe this user lives in a certain, I don't know, house with certain IP address. Like, so basically by this IP address you can say that, yeah, we know that this user is that user because we know his or her IP address. And in our case we decided that, like, well, sometimes it's better not to know those IP addresses because basically we don't want to connect health, super sensitive data with user identity. So we decided to decouple this data. And in order to do that, we had to partner with Cloudflare, and we had to implement this Oblivious HTTP system. And basically the idea is very simple. We have application gateway and application service here. Then we send like encryption key to client, and then we have a privacy gateway. And this privacy gateway has no access to this public key. And client encrypts data with public key. Data is sent through privacy gateway replaces client IP address with different IP address, and then, you know, application gateway can decrypt this data because application gateway has decryption keys, but application gateway can't access IP address. So basically it's kind of clever kind of architecture to preserve data privacy, but it was important for us, so we decided to implement this, even though it's kind of super complicated. You know, like you have this middle party, you have like this all kind of weird encryptions to protect, to encrypt data, and basically like yeah, it's additional complexity for application developers. But it was important for us, so we implemented this. Here you can see like a white paper where we describe how it works at Flow, because kind of privacy goes hands by hand with transparency, and we decided to be as transparent as possible with this solution. But basically here you can see like actual architecture, like Flow application sends data through Cloudflare relay, which replace IP address to another, sends to Flow gateway, and then we have like a lot of application service that have no access to this IP address. Yeah. Yeah, so it was important for us, and we did this, even though it's additional complexity. Another thing which is important for us is time to market. I think it's important for many companies, but for us it's super important, as we have this aim to achieve 1 billion of users, so we have to experiment a lot, we need to learn from the market, we need to grow as a company and as a business, and time to market was super and is super important for us. So what we did, we implemented backend-driven UI. Our application is a mobile client, and basically it means like whenever you want to change something, you have to publish your application to Play Store and App Store, Apple App Store. And typically, it takes, like 2 weeks to go through this cycle. You develop application, you send this to app review teams, they review applications, they release this application to wider audience. Then it takes some time to kind of update all the apps and so on. So basically, the process is super slow, and we decided that it's not for us, and we implemented backend-driven UI. What it means that we have like on the backend side, we can create like a JSON which describes like different screens, and basically these screens, they may have like like video, text, images, blah blah blah. So basically like, and we can play with this JSON as we want on the backend side, and we can change this JSON, like every day, every hour. And I think we do like around like 20, maybe 30 releases per day, and some of them they change UI for end users. And actually all these screens they implemented through the same system, and like even those screens they also implemented through the system. So basically it means that we can play with this UI even though we had to reinvent like HTML and CSS, all this stuff. It may be not very clever for like mobile engineers, but at the same time it was important for us to have very good time to market, and we implemented this solution. You can read here more about backend-driven UI at Flow, but basically with this system in place we can experiment like multiple times per day. And like we have a lot of important stuff at Flow, and we made a lot of decisions, but I want to describe how we manage architecture at scale, how we make all those decisions, and how to keep important things in good conditions. So what we have at Flow, so first of all, like organizational structure is designed for like optimal architecture. So we use this inverse convey maneuver. Basically it means that like we try to organize team structure which is presented here in the same way as we want to see our architecture in future. So as you see here, we have this nice kind of teams aligned with our domains. So let's say we have a chatbots team, we have predictions teams, and also we have like inside the app we have this kind of nice separate screen for cycle predictions, we have a screen for chatbots. It's kind of different domains, and like in an ideal world you imagine our architecture like it should be like one service for domain at least, maybe separate database and so on. So basically like here we have like nicely aligned kind of structure between our application, our org structure, and under the hood we also have aligned application architecture. And we also have this platform layer which is kind of sits on the bottom, but basically we have like a data platform, and all teams they use this data platform, they send data to data platform so we can analyze this data and so on. But basically like this inverse convey maneuver is very powerful, because basically when you create teams around certain domains, they start to change architecture to align it with organizational structure, and it's called inverse convey maneuver. I suggest to read you about this maneuver, and like if you want to change your architecture, just change your teams and it will follow. Another thing that we use at Flow, we make a lot of architectural decisions, and we keep track of all decisions that we make in the format of ADR. I think it's a very popular thing, but now you can see that we made already 800 different ADRs, 800 different architecture decisions. Some of them small, some of them bigger, some of them I've presented today, but basically with every architecture decision record we describe like situation, context, we describe like different options, and then we make decisions and we describe what consequences of such decisions are going to be. So here you can see some of these ADRs. One is this, actually one here is oblivious HTTP for anonymous users, and it's ADR number 4 in a certain team, because basically like all these ADRs, they kind of stored in Confluence, and they kind of, every team has their own set of ADRs, but basically it's possible to go through all ADRs in one place through the search, or you can find why certain decisions were made in a certain way. Another thing that we use is tech radar. So basically, like we have this kind of nice area here in the middle. It's a kind of technologies, tools, or processes that we suggest to adopt, and every team try to adopt them. We also have technologies that we want to deprecate, or I don't know, maybe we want to play with them to understand whether they're applicable to Flow or not. But basically, yeah, we have this tech radar, and every team can access this. And basically, we suggest to use those tools that are here in the middle, basically like in the adopt section. But yeah, it's very good tool to keep your technical stack in a good shape. Yeah, so like not too wide, not too strict. Recently, we also started Architecture Advisory Forum, or basically it's like a meeting where architecture open hours, where anyone can describe different architectures. So here you can see like a logo for architecture decision discussions. So basically, some engineer may present ADR, and then other people, they suggest like changes, or they provide feedback to these ADRs. And we don't have architects at Flow. We try to any engineer make decisions, and we have this forum to share the knowledge and to keep architecture more or less consistent. Yeah, so between teams, between different groups of teams, and so on. It's very powerful technique. Yeah, and we also use them at Flow. So I've tried to I've presented, what is important for Flow. I've described how we keep all those things in a good conditions. But I'm also happy to answer your questions, and I'm happy to talk about other important things that we have at Flow. And yeah, I'm open to your questions now.
I have a question.
Where? I don't see you. Use the mic, please.
I have a quite simple question, I think, regarding this domain-driven org structure.
Yeah.
At what number of people it starts to work?
So actually, when I joined the company, we had 10 engineers, and we had like Android team, iOS team, and basically backend team, that type of structure. And it was okay-ish to have such teams when you are small. It was not perfect because you still need to coordinate a lot of teams, and backend working on something, and Android working on something else, and they always have this dependency issues, and if something done is not properly, they need to interact as teams. But when we hired additional, 5-7 engineers, we realized that, well, it's not working anymore. And what we did, we split this we reshuffled people, and we created one domain specific team. I don't remember exact name, but I think it was something about content or health insights, something like that. And then we also created core team. And we use this core naming because basically we had very nice domain aligned team, and we had everything else. And we just found a perfect name to call everything else. We call it core. Yeah, you can call it engine, or platform, whatever. But yeah, I think starting from 15 people, we started to introduce these domain teams, and then we did several splits like that, and now we have this structure which you can see here on the screen. It's actual structure, and basically here you see that we have different groups. Health, and we call them they also aligned with domains that we have in our app, like health, user-centric, commercial. And then inside every stream we have teams that are domain specific. They completely cross-functional, so it means that they can generate ideas and they can implement those ideas and they can ship those ideas to production. They have iOS, Android, backend, and QA guys. Then we have platform, so basically it's a layer that is shared between all teams, and we have a security team that kind of, it's more like a governance kind of team. They kind of make sure that everything is secure and like compliant and so on. So yeah, that's our structure, but I really suggest to do the same. It's very convenient for the business and it's also good for architecture. Yeah.
Thanks.
Thank
I
you.
only asked for a number, but thanks for a very detailed answer.
Yeah. Thank you.
How you deprecate your architectural decisions, how you generally manage them, how you verify that they actually work in the long run, and do these architectural decisions has any kind of expiration policies?
Yeah, it's a good question. I don't think that we really deprecate like all decisions. We make new decisions, and sometimes you can find like several decisions about the same topics. But what we try to do, like we try to use this architecture open hours to discuss some of the decisions that we made. And in ideal world, I'm not sure whether you see this kind of agenda or not, but like in ideal world, it also should include, like some retrospectives or kind of review of previously made decisions to kind of learn whether they're right or not. But yeah, we don't really deprecate, we make new decisions. It's kind of like always forward-thinking kind of approach. And I think the biggest challenge is actually migration for us. Yeah, so sometimes, 4 years ago, we did the decisions to use Kinesis as our streaming platform, and we already migrated to Kafka for 2 years, from Kinesis to Kafka for 2 years. This migration is still somewhere in the middle, and I think this is one of the hardest things. Because yeah, it's kind of like, when something works, like nobody really wants to invest a lot into this, but at the same time, it's kind of important to move from one decision to another when you made the mistakes. And yeah, I think migration is a very hard thing for us, and I'm not sure whether we know how to do this properly or not yet, so I don't have like a silver bullet how to make those kind of migrations from one decision to another. Unfortunately. Yeah. I'm not sure whether I answered your question, but I hope so.
Hey, I'll come up front.
Sure.
So the important question, this is an architectural meetup, so quite a lot of architects here probably, and that might have ring a bell. What you say, you don't have architects. How do you find the balance when young people try to adopt fancy new technology, and how do you manage to make good architectural decisions? For example, this like Kinesis, maybe it was an error, erroneous decision because you didn't have grown-up architects. What do you think?
Makes sense. Yeah, it's a really good question. I think it's important to mention here a few things. So when I say we don't have architects, I actually mean that like anyone is architect. So even if you kind of any decision is basically, if it's about important thing, it's an architectural decision, whether it's made by architects or like junior people. Yes, it's in reality we have architects, like anyone empowered to be architect. Second important thing to mention here is we don't really have like really junior people. I think at Flow, at least, currently we have most of our engineers senior, and it means that they have at least like 10 years of experience, sometimes more, sometimes 15, sometimes 20 years of experience. So basically, maybe it's not applicable to this kind of environment where you have like a lot of juniors, but at the same time, we also have this kind of guardrails or like quality gates, like tech radar. So if you want to introduce like a new technology, you need to add this to tech radar. And you need to go through some kind of process to introduce new technology. Yeah, you need to kind of create this pull request to backstage to add new technology, and someone senior will check this. Also, we have this conference pages, and senior people, they can write comments, they can make suggestions, and so on. We have open hours where like juniors people will present those ideas and they will receive feedback. So I think it will work in an environment where you have juniors, but I think it should be balanced. Like if you have juniors, you also need to have like good portion of seniors who help those juniors to grow over time. Yeah. But at Flow we are lucky enough, well, maybe not lucky, I'm not sure whether it's good or not, but we don't really have juniors.
Thanks for the great presentation. So, something I learned, I never heard about this backend-driven piece in the apps.
Yeah.
And my question is more related to the kind of, in general, when you hear about architecture, for me it usually connects with infrastructure.
Yeah.
So, what's the infra piece of that Flow works on? I heard Kinesis, so probably AWS, right?
Yeah.
But how does this architecture work on the infra piece?
Yeah, it's a good question. So yeah, we heavily rely on cloud. So we use AWS as our primary cloud, and we use a lot of kind of managed services like managed Kafka service, I don't know, Aurora database, you know, like managed Kubernetes and so on. I don't think that I have like a good answer to explain our architecture, but it's kind of very cloud native, but at the same time we also kind of default to all open source standards, let's say, or like, you know, we prefer like PostgreSQL interface over some kind of, you know, like proprietary Amazon thing. But actually it's very traditional, you know, like we have Kubernetes, we have a lot of services, they talk to each other through REST APIs or through, you know, streams like Kinesis or Kafka, whatever like is adopted at a particular time. What else to mention? We also rely a lot on Cloudflare, which is our kind of like edge infrastructure, and we use CDN from Cloudflare, we use web application firewall from Cloudflare, we use network, special network, which is super fast between like different regions, which is also provided by Cloudflare. So I think, you know, these two providers are the most important. We also use Terraform to manage all this infrastructure. And here on these slides we have one team which is responsible for our cloud infrastructure. So basically it's a velocity team. We also call them cloud platform from time to time. But basically this team, in this team we have like around like, Anton, could you please remind me, 4 or 5 infrastructure engineers. And they also have like a lot of Terraform repositories, and any team can send pull requests to this team. So let's say, I don't know, storage team needs a database. Yeah, we have a module to create a new database, and you can send, you know, like pull requests to Velocity team to create like a new database, and it will be reviewed. It will be deployed to production through, you know, CI/CD process, which is kind of which is used with Terraform in our case. And in this way we kind of try to keep this infrastructure in a good shape. And we also have some, you know, like tests on top of this repository. So we use Sneak to validate whether like we have any security vulnerabilities in Terraform. So like Sneak can check whether we have like, I don't know, security group which is open to anyone. You know, we use like different other tools like Orca Security, I think. We will have a presentation from them. It's also deployed in our environment. So basically, I think the short answer to your question, yeah, we rely on cloud a lot. We have team which observe or kind of make this infrastructure piece, but any team can contribute to that. Yeah.
Right. So it's kind of a mix between serverless and servers.
It's, yeah, we have servers, yeah, and but we prefer not to have them. Yeah.
Yeah. That's more of a feature. Thank you.
Thank you.
The first, yeah.
Thanks. Actually, I have 2 questions. The first one is how do you manage alignment between business guys and technical guys? I mean, you know, different groups of people even speak in different languages.
Mm-hmm.
Like business persons don't even know about like Kafka, Kinesis, and no one. And how do you manage and how you explain your IT stuff to the business persons, get an investment into your some IT activities and so on.
Yeah. I don't think that we talk a lot about like technologies with business. I mean, like we try to talk with them like business language, and that is why we also have teams which have like a business names as well. So it's very easy for them to understand like, well, we need to introduce like a new feature on onboarding, and we have like a special team which is called onboarding, so they can talk to this team. So it's kind of like we try to adapt the same business language. And we try to speak with them like using the vocabulary. Yep. And I think what is important here is that we also use like OKR framework. OKR. It's a special framework which is used to set the goals for the teams. And let's say every team has their own OKR. So let's say onboarding team has objective like to increase conversion from 5 to 10%. And I don't know, some other teams, they have other objectives. And it's one objective for the whole team, including like designers, product managers, and engineers. And then they work together to achieve those goals. And sometimes in order to achieve these goals, you need to move from Kinesis to Kafka because Kafka is more performant, or it has, it has better scalability. Or let's say it's important for business to release more features so they can support, these backend-driven UI initiatives and so on. So typically, it's better to talk, business language with business people. For sure, we try to explain all those things like Kinesis, Kafka, blah blah blah. Why we spend a lot of money and time to migrate from Kinesis, let's say, to Kafka. But we try to talk, about money, investment, like how we will increase. I don't know, time to market, responsiveness of our app, and so on. Yeah, so I'm not sure whether it's answered your question, but I hope yes.
At least partially.
Yeah.
So, and the last question, if you care a lot about security stuff and governance, how do you manage continuous security development lifecycle in your commands, for example, maybe continuous threat modeling like a Stride model or something like that? I can explain a little bit more why I'm curious about this question. A few years ago, I've worked at SolarWinds, and if you remember, we were hacked a little bit. And so after this event, we started to care a lot about security, and we've started to invest a lot of money into introducing a security continuous life cycle into our commands, some security threat modeling sessions and so on. And it's interesting to hear about your experience in this area. Thanks.
Yeah, makes sense. Yeah, so I think it's important to mention here that we try to shift all security-related activities left, like closer to developers. So basically it means that like we have a lot of security checks, in CI/CD pipeline. So like with every commit we go through like, I don't know, static code analysis, like dynamic code analysis. I don't know, when we change infrastructure, we go through Snyk to check whether it's kind of compliant with our rules or not. We also use a lot of like different metrics to measure security. Let's say in our Amazon environment, one of our important metrics is called, I forgot like exact metric, but basically it's kind of cloud security score, which is kind of Amazon metric, and basically they have a lot of kind of controls and they check how many of them are implemented, and basically we use this as a metric to make sure that our cloud is secured and protected. We also have other metrics like, I don't know, amount of vulnerabilities, time to close vulnerability, and so on. And basically like every team is responsible to keep those metrics in good shape. So whenever we have an issue, I don't know, let's say with database which is owned by an onboarding team, they will receive notification from our security team, or they will receive notification from security CI/CD pipeline, and they will fix it. It's also important to say that we also have this, bug bounty program on HackerOne. We have, continuous, we have application security specialists, and they try to kind of hack our system like every time. So it's kind of like, a mix of different tools and technologies. and processes. And our main kind of driver for security is ISO standard. We use ISO as a kind of, I don't know how to call it, like guiding principle for our security program, because basically, yeah, we recently achieved ISO certification, and I think it's very good framework, because basically you think about risk, you assess them, and you make certain decisions based on those risks. Yeah, so again, not very concrete answer, but hopefully I've answered some of the things. And if you're interested, you can talk to me after the presentation. I will show you some of the things in real life on my laptop.
Hey, thank you for presentation. I suppose you've been asked this question quite a lot,
Yeah.
but anyway, I'll ask it again because I feel it's also an important thing. It's about data privacy. It looks like in your domain it should be like one of the most critical issues.
Yeah.
And what do you use for this? Like any architectural decisions you made, like any novel technologies?
Yeah. As I mentioned already, like we use this oblivious HTTP. It's one of our one of the standards that we adopted, especially particularly to protect data privacy. But we also have like other things in place. Like we have like a separate PI storage, which is kind of separated from other databases, and all PI data is stored in one place. It is encrypted, like, I don't know, multiple times on different levels, like, I don't know, disk level encryption, then, database level encryption, field level encryption, like all this kind of stuff. So PI storage we have in place to protect personal identifiers. We also have like different tools to make sure that PI data is stored only in PI storage. So right now we are working with Big ID technology to kind of set up this continuous scanning for all our infrastructure, for all storages, to make sure that there is no PI data somewhere else, like in I don't know, other storages. And like it's a big topic, and I think what we've done properly here is that we have this data, how it's called, like DPIA. It's a data protection impact assessment. So whenever we implement like a new feature, we think about this like from how we need to protect data, what kind of controls we need to introduce, and we work with our privacy team to kind of design proper solution. We also have like a separate team. I'm not sure whether it's shown here on the slide, maybe not yet. Actually, yeah, it's here. So we have like a separate team which is called Trust, and this team develop a lot of tools to kind of make sure that like whatever we do is according to best practices in the privacy world. And now we also work a lot with Cloudflare, because they also, like, Cloudflare is very privacy focused infrastructure company, and we work with them on some new tools to kind of protect privacy and further. You can read about this in Cloudflare article about like privacy by design or something like that. You will see some good names there. Yeah.
And the last question.
Sure.
Yeah, so the last question, very connected to the previous one. You operate in a domain where you even have medical records team, and this definitely creates a lot of challenges for architecture. For instance, in relation to different markets regulations, and you also mentioned your goal is to get to 1 billion users. Your goal is to get to 1 billion users.
Yeah.
So this will probably also require going into markets that have entirely different regulations and different constraints. And what are the challenges you are facing in that area right now, and how do you plan to deal with them?
Yeah, from this perspective, it's important to mention that we are not obliged to be HIPAA compliant, FDA compliant, whatever. So it's more like we still kind of health and fitness app in the kind of. But at the same time, yeah, you're absolutely right. We're working on some chatbots to detect like different health issues, conditions. We have this medical records team and so on. So we work in this direction a lot. And for that, like from privacy perspective, we try to be compliant with GDPR in all countries. It doesn't matter whether it's kind of, I don't know, somewhere in Poland, which is kind of part of European Union and GDPR is applicable here, or it's, I don't know, some other countries like, I don't know, Brazil or whatever. So we try to kind of use the strictest kind of standard to protect data privacy. We also have certain tools to make sure that like whatever we do will be compliant with HIPAA, let's say, because it's also very important kind of law to protect health data. Even though it's not applicable to us, we already have tools that, like, let's say we use Wanta and we have a HIPAA module, and basically we scan all our infrastructure to make sure that all controls that are required by HIPAA are implemented in our case. We also have this PI storage to concentrate all those things in one place, but I think here is important to make sure that, you know, like, we have like kind of every time when we release feature, we work with medical team, we have a medical affairs team, we have privacy team, legal team, security team, you know, engineering teams, and so on. And basically, it's very kind of sometimes it takes a lot of time to push some of the features to production, just because you have to go through all this kind of people and all this kind of regulators and, you know, all this stuff to just release like, you know, one button on the UI screen. And yeah, it's kind of a big challenge, but I also think that it's possible to solve some of these issues with technology. So if you have a PI storage, it makes it much easier for everyone to release features because they don't deal with personal data, like personal identifiers. Or if you have like a, I don't know, something related to chatbots and kind of health things, it's better to consolidate this stuff in one team, and you can train this team in a special way, and you can design, you know, systems like in a special way. Like you don't need to design like medical records system in the same way as you develop, you know, like paywalls. Like it's kind of different domains. You can play differently with, you know, technologies in those domains, and you can use some technologies that are not applicable in one thing, in one domain, in another domain, and it's better to have like those domains in separate teams, so that they will know like what kind of environment they have and how they have to work with it inside this environment. Yeah. Hope it answers your question, but yeah, again, we can talk about this after my presentation. Yeah.
Yeah. Thank you very much.
Thank you.